Here we have a SAT math problem. Okay, let's go to the question. In the xy plane above, the graphs of line L and line M intersect at point P. If line L is perpendicular to line M, what is the length of OP? So we have to find the length of this line segment OP over here. Okay, now let me name this point as A and this point as B. Okay, so here let's consider the point B over here. That is 4, 0. The exponent is 4. So that is the length of this line segment OB is of 4 units. And now let me consider the point A over here. That is 0, 3. Since the y coordinate over here is 3, the length of this line segment OA is 3. Okay, now let's find the area of the right triangle OAB. Actually, we have right angle over here because in any xy plane, so the angle must be between the x-axis and y-axis, right angle. So it's a right triangle OAB. Let me get the area of this right triangle OAB. Let me write the stuff over here. Area of triangle OAB. So the formula to get area of a triangle is 1/2 times base times height. Okay, here 1/2 times. So what is the base of this triangle? The base is given by the length of the line segment OB, that is 4 units. We can plug in 4 for base. And the height of the triangle is given by the length of the line segment OA, that is 3 units. Okay, 2 goes into 2 1 times and 2 goes into 4 2 times. So 1 times 2 is 2, 2 times 2 is 6. Now I got the area of the triangle OAB, that is 6 square units. Okay, now let me approach the area of the same triangle OAB in the other way. Now, so for this triangle, right triangle OAB, let me consider this AB, the hypotenuse, as the base of the triangle. When I consider this one as the base of the triangle, then this OP represents the height of the triangle. Okay, now let me get the area in this way. That is area of triangle OAB equals to 1/2 times base times height, the same formula again. But this time I'm going to consider this AB as the base. So what is the length of this AB? As I said already, OAB is a right triangle, and so these two are the legs, and AB is the hypotenuse. And clearly, this is 3, 4, 5 right triangle. That is, when the lengths of the two legs of right triangle are 3 and 4, then the length of the hypotenuse must be 5, or even we can use Pythagorean theorem to get the length of this hypotenuse AB. Anyways, the base, since we consider AB as the base of this right triangle now, so the base is 5. We can plug in 5 for base over here. And the height of the triangle is given by the line segment over here, because the OP is perpendicular to the base. So we can consider this OP as height of the triangle. So let me plug in OP as height over here. Then we get 1/2 times 5 can be done. Actually, it's 2.5. That is 1/2 of 5 is 2.5 times OP. Okay, now I got the area of triangle OAB in 2 ways. So here is the first way, that is 6. In the second way, I got 2.5 times OP. Anyways, both of them represent the area of the same triangle OAB. So we can equate them. That is 2.5 times OP equals to 6. Okay, my aim is to get the length of OP. So I have to solve for OP in this equation. For that, let me divide both sides by 2.5. So when I do so, this 2.5, 2.5 will cancel out. Then OP equals to, okay, let me divide 6 by 2.5. When I divide 6 by 2.5, I am getting 2.4. So the length of the line segment OP is 2.4.